Okay guys, welcome back. We have a question from my student who just messaged me just now. Alright, we have this, we are required to find the volume of 0.1 mole per cubic decimeter, right, of hydrochloric acid that is required to react completely with 25 cubic centimeter of 0.1 mole per cubic decimeter of aqueous sodium carbonate. Alright, let's get going. Okay, let's try to do this. So we first write the chemical equation, right? So we have hydrochloric acid, HCl, right? Please put aqueous. Without aqueous it is not an acid. If it is not an aqueous state, it is not an acid, right? Hydrochloric acid plus your aqueous sodium carbonate, Na2CO3, right? Aqueous sodium carbonate, and that will give you an acid react with metal carbonate here. That will give you sodium chloride, right? Sodium chloride, okay, NaCl, right? Obviously NaCl will be still in aqueous state, and of course they have hydrogen and oxygen there. You're gonna have water, H2O, in liquid form, and last but not least you will have your carbon dioxide, okay, CO2, gas, gaseous state. Okay, now what else can we do? We have to balance the chemical equation, right? So we have H2 here, so no problem, we put 2 there, and once that will be Cl also 2, so we have to put 2 here, right? And I think that's all about it, isn't it? Yep. So we have 2 mole of hydrochloric acid react with 1 mole of sodium carbonate to produce 2 mole of sodium chloride, 1 mole of water, and 1 mole of carbon dioxide. Okay, and what else? How we proceed? Well, we use whatever we are given, right? Sodium carbonate, and Na2CO3 aqueous, right? Based on that, we are given the concentration 0.2 mole per cubic decimeter. That means 1 cubic decimeter. And since we are given they react completely with 25 cubic centimeter of this concentration, so we have to change the 1 cubic decimeter to cubic centimeter, so it's 1000 cubic cm, right? So since they only use 25, so from there we can find the mole of your sodium carbonate that will react. Therefore, number of mole of sodium carbonate, Na2CO3 aqueous, will be equal to 25 divided by 1000, right? 25 divided by 1000 multiplied by 0.2, right? So you realize that if you use this method, you don't have to use any formula, right? That will give you 5 times 10 to the power of negative 3 mole, right? That will be the number of mole of sodium carbonate. Alright, so we realize that from the balanced chemical equation, the acid is 2 mole, the metal carbonate is only 1 mole. So therefore, in terms of the ratio of your HCl is to your sodium carbonate is to 1. 2 mole is to 1 mole, right? So we do not know the mole of your acid used. Don't forget to put AQ, right? If I put AQ here, we know that the mole for your sodium carbonate is 5 times 10 to the power of negative 3 mole, right? That will give you therefore number of mole, right, of your HCl, right, will give you 5 times 10 to the power of negative 3 divided by 1, right, multiplied by 2. That will give you 0.01 mole. That will be the number of mole of hydrochloric acid used. Okay, that's one thing. After that, what else can we proceed with? We know that we were given the the concentration of hydrochloric acid, right? 0.1 mole per cubic decimeter. So we make use of this. Okay, therefore using that one, 0.1 mole of HCl, AQ, hydrochloric acid, 0.1 mole per cubic decimeter, 1 cubic decimeter, change to 1000 cubic cm. Okay, and we know that we only use 0.01 mole, much lesser, right? Obviously that will give you the volume of the HCl that was used, right? Therefore volume of hydrochloric acid used or required will be equal to 0.01 divided by 0.1 multiplied by 1000. Done deal. That means 0.01 divided by 0.1 multiplied by 1000 cubic cm. That will give you 100 cubic cm. That means 100 cubic cm of hydrochloric acid is required. Simple. No formulas required. It's very easy, isn't it? That's all, guys. Thank you very much. Take care. Have a nice day.